In this video, I'm going to look at general solutions, and I'm going to give you an introduction to what I call option B. And you'll notice this type of general solution when you have different functions, so sine and cos, but the same angle. And so the trick in this case is just to divide by cos. Obviously, cos of whatever angle is the same. A matric would battle more with this than a grade 11 because they would be thinking compound angles and wanting to expand this into something really big and ugly. But you want to discipline yourself as a matric, and as a grade 11 you wouldn't be thinking about all this compound angle stuff, so you dive straight in and go, if I see the same angle, all I'm going to do is I'm going to divide both sides by cos of that angle. Why is that nice? Because sine over cos becomes tan of that angle. Be careful not to think that you just cross out the 2x plus 10 like normal algebra. So that's the one trick. The other is on this side, cos 2x plus 10 cancels completely with the denominator and I'm left with minus 8. So now, the minute that you've done that one little trick of dividing by cos, you're actually back at option A, which is where you've got a function sine, cos, or tan equaling a number. How do we always do reference angles? With me, we always try and see what quadrants I'm in. So tan is negative. So where's tan negative? It's in quadrant 2 and 4. So I've ticked them. And then to get a reference angle, you can either just go shift tan of 8, and that will jump you straight to the reference angle. Or if you go shift tan of minus 8, you must just immediately add 180 so that you end up back at the same reference angle. The reference angle you always ideally want to have as acute, because then when you're thinking, I'm in the second quadrant, how did I get there normally? It's 180 minus the reference angle. I'm in the fourth quadrant, 360 minus the reference angle. And so I like this method, even though there are other types, just because it links to the other sections of reductions. And so you've got the angle, 2x plus 10 equals 180 minus the reference angle, plus k, 180. It's normally k 360 for sine and cos, but for tan, the period, the 180 represents a period, is 180. And similarly, in the fourth quadrant, we have 360 minus plus k, 180. At this point, it's helpful to get that one extra mark of just saying k is an element of the integer. And then you're just simplifying from here, taking things across. For tan, uniquely, you don't need to give both sets of quadrant answers, because tan will perfectly duplicate back and forth on itself because the period is 180. So if I add 180 to this answer, then I'm always going to end up back at the other option for general solution that I had. I'm just including both as a discipline, but just be aware when you look at various memos, don't be surprised if you just see one answer. To finish it off, I've divided by 2, and that gave me my final answer. And so these two are my general solutions. The next question that typically will follow is to ask for a specific solution, or they'll say solve for x. And so here's a random domain that I've made up from 10 to 200. And so what you'll do is you'll start by saying, is this angle that I got in my general solution, is that somewhere between here? And 43 is, so it will be an answer. Then if I added the number that's with k, I just added to that, so that's 133.56. Is that still between here? Yes, so it's also an answer. If I added another 90 to this, I would end up with 223.56, and that's just too big. And so then I know that these are my only two answers. Typically, you would have done the same in a normal general solution question, looking at this number and seeing if it fits in between. But like I said, because tan duplicates onto itself, I've already got those answers from the first one. So I hope that you found that helpful for general solution and what to do when you notice you've got the same angle but different functions. You just divide by cos. If you found that useful, please like this video, subscribe to our channel, and share this with your friends. Thanks.